welcome back. Last time I saw most of my students, it was on campus a couple weeks ago, and I was telling them that you don't have to panic if anyone's ever told you you're illogical. I want to keep that idea true. There are standard rules of reasoning that we apply to logic. Most important, standard and rules. Okay, you have to abide by the standard. You can't freelance on this. This isn't art or music. This has to abide by a set of rules, so you have to just accept that that's where we are. What goes on with the logic of truth tables? Truth tables deal with true and false. Now, what do they want to do? They want to go with T for true and F for false. If you notice, they look an awful lot alike. So some people, when they're not sure whether they want to say something is true or false, they'll try to give me what I call a TEF. And when they give me a TEF, I'll draw it really large for you. Here's what they do. They go like this. Okay, now if you can see, then I'll say, oh, too bad you gave me an F. That's supposed to be a T. They're like, oh, no, that is a T. Look, that's a little thing over the edge here. I'm like, oh, and what about that? No, that was there. And then the other thing is, I'll say, it's too bad that you gave me a T when I needed an F, because, that's making it a T. Like, no, that just was this little, come on, don't worry about it. And that's really some bold F. No, you have to take a stand. If you give me a TEF, something like that, it's embarrassing for you, and it's just embarrassing for you. It doesn't embarrass me, but I'm letting you know I'm going to mark it wrong. If you try and get 2 for the price of 1, you're going to get completely marked wrong. So take a stand, make a guess. Maybe you'll get lucky. Maybe you actually know what you're doing. But don't try and pull the wool over my eyes with a TEF. It's not going to work. T and F do look an awful lot alike. So we don't have to write out the word true and false. We write T and F, and we have to clearly show each person what it is that we're writing there. Now, truth tables list all the possible permutations. You've heard that word before. Permutations means order counts. That's why the rules of truth tables have a set order in which your answers need to turn out. You can't say, hey, I got the right 8 answers, they're just in the wrong order. That's wrong. You have to stick to the standard rules of reasoning, and therefore you have to put them in the same order of true and false pairs. Now, there could be 2 of them. If you have one thing where they wind up with, you know what, we got something could be true or something could be false. Or there could be 4 of them where you say there's another one where we say something could be true or something could be false, but maybe the first one is true both times and the second one is false both times. Wait, what? And now this happens. But you might have 8. Now we had 2, doubled it to 4, doubled it to 8. What's happened now is I began with green. Let me go with green and put the original true and false. If there's just one thing we're looking at, is it true or false? We can have it true or false. We always begin a new cycle with true. The simplest true and false is something like this. Is it true that the light's on? It's true. It's false. It's true. It's false. It's binary. You've heard of binary lately in other fields out in society. Well, binary means you only have 2 choices. And so true and false are the only choices that we have. We got to represent all of the binary ways that true and false can get there together. Now, what happens if we say, wait, that's if we want to look at 2 possible things. How many ways can they pair up? And let's start with truth first. The last column is always 1 at a time. The next column will be 2 at a time. And if we go to another column, it'll be 4 at a time. Because what I'm going to do is I'm going to go the same thing that I had, TF, TF, for the last column. That's 1 at a time. Also coming in on the second wave was 2 T's followed by 2 F's. Now what I have is the top and the bottom halves are exactly the same. And now we're going to wrap this up by saying I want all the first 4 to have T show up first, and all of the last 4 have F show up first. And now, if I name for you a permutation of T's and F's, 3 in total, TFT, it's only up there one place. I just said TFT, I'll go find it. TFT, there it is. It's only here, and every one of them is up there. FTF, it's only up there once, but it is up there once. FTF is right here. Okay. TTF, right there, only once. All of them are up there. You cannot come up with one of those sets of 3 in order combinations of T and F that are not up there. You also will not come up with any that are there more than once. How do we do this? Well, that came from the process like this. Number 1, the last column is T over F. And that's one at a time. Then the next column, the next to last, is 2 at a time. So when you did that, we said TF, that was green. Now what happens is I'm going to repeat the TF and the TF, so I have 4 of them lined up, and I give you 2 T's followed by 2 F's, and I get that. That was a representation of all 4 possibilities if I had just 2 slots to fill with T or F. The one before that is 4 at a time. Always start, always lead with T. That's the process of building this. Because what's going to happen is we might have something like this, P, Q, and maybe R. They can be in different letter orders, right? X, Y, and Z are taken, A, B, and C are too popular and all that. P and Q are the most common ones that people use. If we only have 2 variables, we tend to have P and Q. If your statement has a letter that works well for it, that doesn't look like an O or an S, where it'll look like a 0 or a 5 or something like that, your statement might grab the letter for what it's standing for. But these are lowercase letters that stand for what we're doing, what we're looking at for our statements that we looked at before. They are lowercase. You also don't have T as one of those lowercase names of a statement, and you don't have F as one of those lowercase names of a statement. You could, because the T and F are the only capitals that we use to stand for true and false, but they fill the body of what goes on under there. And any properly created one will either have 2 or 4 or 8 or 16. And can you guess what the next one would have if we did it, which we're not going to do because we didn't even write the 16. If I were doing the 16, I would create these 8 rows again, put 8 T's followed by 8 F's and get to 16. After 16, we would go to 32. And it could go on forever. We always start with the last one being T and F, so that no matter how far we have to go, we will have room to expand to the left and fit it. What's the good news? Is most of the work we do in this course will deal with, they've already established the position of T and F, and you just have to fill out what it is when we assess what these logical statements are saying about it. So I'm going to leave that for you in the video right here. I'm going to take it down because I don't need that to be lasting. I have lasting things that are going to go on that board. These are going to be built for you in Connect Math, and I even build them for you when I write up the tests that I hand out, because it's not about me saying, oh, I hope they can build their own truth table. I hope that you can assess using standard rules of logic what rules come out of there. And what we have are these operators, and these are binary operators. These are TF operators. An operator does an operation, and we're going to do 3 right away. We're going to get into them, and they're going to deal with things that you can see in the real world. And I'm going to show you just 2 things that we have and or dealing with, and we'll get to what the reality is for that. Then we'll create a truth table for P and Q, or maybe I'll give you a different name for the letters and all that. But here's what we have. We're going to look at and. Okay. I can say I'm wearing a hat and I'm wearing a watch. And so I'm going to say that I have H and W for these things. So I'm going to go ahead and use H and W for hat and watch. H will be, do I have a hat on? W will be, do I have a watch on? Better curl this back. I know, it's on my phone too, but I've gotten used to it over the years. So anyway, what I want to do is, instead of saying P and Q, I certainly could do that. I'm going to say, let's have a hat and a watch be possibilities. And I know that I need 4 of them, but you don't have to know that I need 4 of them. I'm going to go like this. I want to build up the possibility, if we don't even think about my hat, it's possible true that I have a watch, it's possibly false that I have a watch on. And that's it, TF. And if I was only looking at watch, the only possibilities are true or false. But now, what comes along next is I'm going to consider the opportunities to have a hat. So I need to repeat this TF to set up all the possibilities when I go 2 at a time, starting with true. So 2 at a time is T and T, and then false and false. And there's all the possible, and I mean it when I say permutations of T and F for 2 slots. You can have a double T, a double F, a T before an F before a T. T before an F is a hat with no watch. F before T is a watch with no hat. Those are different situations. Right now, I'm wearing both. Right now, we are in the first line. And what I'm going to do is have you understand that and is going to have this symbol. It's an upside down V. And we're going to see what happens. This is H and W. I want to say, do you say yes or no? Yes is true, no is false to what's going on right now. And that is, we're saying, here's the guy who happens to be wearing a watch and a hat. Am I wearing a hat and a watch? The answer is yes. And therefore, that one is going to be true. It's true that I'm wearing a hat and a watch. Okay, now we have a guy who keeps his hat on, but comes in the room like this, and we're assessing what that's like. And here comes the guy, and he's in the room. And we say, does he have on a hat and a watch? And you look at the hat, and you say, yeah, he's got the hat. Let's keep looking. Does he have a watch? No. Do I have both a hat and a watch on? And you say, no, and therefore that's false. And therefore what we're going to do is say, needs both. And we're going to expand on that in a little while. All right, so now we're going to judge a different person that comes in the room. My hair's probably pretty matted down. That's all right. No judgment, I hope. Here we go. Here comes the guy with a watch on, but he does not have a hat on. And you're looking at the two things, and you say, does he have on both a hat and a watch? I threw in the word both to help you with that a little bit, because it needs both. Does he have on a hat and a watch? And you look and see that he has no hat, and his hand is behind his back. Do you know, does he have a hat and a watch on? Just by seeing no hat on his head, it's over. Because he can't have both if he doesn't have the first. So that's false. Turns out I did have a watch on that time, but did I have both? No, so that's false. Now here comes this guy. Modern guy, got his cell phone, loves his head of hair, no hat, walks in. Wondering if that guy has a hat and a watch. You can tell right away, seeing no hat, it's over. No, he doesn't have both. Does he have a watch? No. Does it matter? Not when he didn't have a hat. It did matter when he had it. You know, if he had a hat and we looked at watch first, we would keep looking. You know, if we looked at hat first, we had to keep looking to see if the watch completed the package. But this guy didn't even get out of the gate. What does that mean? And, symbolized by that, which is an upside down V, needs both T to be T. The key is, I wrote we need both. If you get both, you deliver a truth for the and. Let's get back to my more comfortable hiding under my hat and behind my watch. Let's get back to it. Let's do or. Or is a vertical regular V. Let's see what goes on with or. We'll get our answers for whether I'm wearing a hat or a watch. And my daughter took a statistics class. I used to always say here at Norwalk Community College, but I'm not there right now. She took the class there, and the only thing she got wrong on the final was something dealing with or, because she then had a discussion with her professor, who of course was not me, friend of mine, but anyway, he said, we were talking after it, and he goes, yeah, she had a very interesting argument because of the word either. The word either is not involved in this. Okay, if you say either or, then you can only have one of them fit. That is not what we're doing here. You might have to be explicit and say this is not the exclusive or, this is just or. Or means you got to qualify somehow to tell me that it's good. So here's what we've got. We've got the hat or the watch. In I roll, hat and watch on. And you just see me with my hat, and you're wondering, does he have a hat or watch on? Not a hat or a watch, exclusively only one. Does he have at least one? And when you see the hat, then you know. You see the hat, and he's got at least one. He may have the other one. He does, but that's okay. So does he have at least one? That's true. Does he have a hat or watch? Yeah, I knew that when I saw the hat. Now in comes the guy, different guy. You're going to assess the truth or falsity of this, and his hand is behind his back. And he walks in and you see the hat on his head, and he needs at least one, and you got the first one. You don't have to worry about what's going on behind his back because you only need one to have or be true. So he's got one. He's got at least one. If you catch a glimpse of where his watch would be, you see he's got exactly one. That's or. That's good for true. And then we got the other one. We got this guy with no hat. Does have a watch on. He walks in the room with his hand behind his back. And you see him with no hat. Can you decide from across the room if he's got a hat or a watch on? The answer is no. His hand is behind his back. The hat did not deliver. But you need at least one. You still got a chance for redemption with a watch. Eventually his hand comes out. You see he's got a watch. That does it. He's got at least one. This time it's the watch. True. So does it have at least one true to be true? Why? Because of this. Fourth guy walks in the room like this, no hat. So you initially say, does he have a hat or a watch? From across the room, all you can say is maybe. And then you got to see about the watch because that's either going to redeem it or not. No, another no. That means it's false that he's got a hat and it's false that he's got a watch, and it winds up false that he has at least one of them. And that's our or rule. Some people come up with another or rule. I'll speak it twice, but I'm not going to write it on our board. You can write it in your own notes from what I say twice and play it back on the video if you want. Some of my students say that for and you need 2 T's to make a T, and they think that for or you need 2 F's to make an F. If you look, that is true. These are the originals. If you have 2 T's, your and is a T, otherwise it's an F. If you have 2 F's, then your or is an F, otherwise it's a T. So what they said was you need 2 T's to make and be T, you need 2 F's to make or be F. That sounds like people trying to make a game of it or something they don't understand. But what you really have to understand is you need both true to be true, or at least one to be true when you have an or. So if I say, again, Norwalk reference, if I say, meet me at Route 1 and Walmart in Norwalk. You meet me there, we have to be at both, and I'm going to be able to see you if you're at that corner. If I say, meet me at Route 1 or Walmart in Norwalk, then you could be anywhere on Route 1 because you're good for the Route 1, or you could just be at Walmart Norwalk, and there's no guarantee that we're going to meet. That's why this is called an intersection, and this one later will be called a union. Okay, so we got one other thing. There's this squiggle line. I don't know how to pronounce it, but some of you speak Spanish well, whether it's a tilde or a tilde. I think it's a tilde, but anyway, it's similar to the thing that would be over enye, right, in that letter that we don't have in English. And that means negation. So we're going to have the negation. Now the negation is weird because all it does is it reverses a single truth value. So the tilde, as some people call it, or the tilde as I call it, sits in front of one variable and it will reverse that variable. So I'm going to do the negation of H, which means look at what H has and reverse it. Reverse true to false. Second one, reverse true to false. Third one, reverse false to true, and take your guess at what the next one does. Where I'm still reversing H, its value on this line begins as an F, and it reverses to true. But you can only take negation of a single value. How about if I take the negation of W? I'll get you started. If you're good at it, speed it up. If you're way good at it, play it, or stop it and fill it in. Way good at it, try and beat me to it. But what I'm doing here is I'm looking at W. W is all that I'm reversing. This has nothing to do with what happened in H. Reverse T to F, reverse false to true, reverse true to false, reverse false to true. You're doing one thing at a time. You're not memorizing how the line goes. You're making an assessment of what that operation does. So I'm going to stop here. Those are the definitions that we're going to rely on as I go into how to do work in Part B.